Hello student, now we'll start the chapter number 2 from the maths part 2, that is the parallel lines. In this chapter we will study the properties of the angles formed by the two parallel lines in transversal and test for the parallelness of the two lines and use of the properties of the two parallel lines. Also we'll first derive the interior angle theorem by using the fifth postulates of Euclid's, and using that we will prove the theorem for the alternate angle theorem and the corresponding angle theorem, and lastly we will solve the practice set 2.1. Now let us start. Parallel lines. Let us study the properties of angles formed by parallel lines and its transversal. Test of parallelness of the two lines, that is we are learning in this chapter. Use of properties of parallel lines. Now let us recall, that is the definition of parallel lines. The lines which are coplanar and do not intersect each other are called parallel lines. Now in this figure, line L, line M are the two parallel lines. Do you recall the pairs of angles formed by two lines and their transversal? Yes, we can recall it. In figure, line N is the transversal of the line L and line M. Here, in all, 8 angles are formed. These are the A, B, C, D, E, F, G, H. Pairs of the angles formed out of these angles are as follows. Pairs of corresponding angles, that is angle D, angle H, angle A, angle E, angle C, angle G, angle B, angle F. These are the pairs of corresponding angles. Angle D, angle H, angle E, angle A, angle E, angle C, angle G, angle B, angle F. Now the pairs of alternate interior angles, that is angle C, angle E, angle B, angle H. These are the pairs of interior alternate angles. Now next, pairs of exterior alternate exterior angles, that is angle D, angle F, angle A, angle G. These are the alternate exterior angles. Now the next, the pairs of interior angles on the same side of the transversal, angle B, angle E, angle C, and angle H. These are the pairs on the same side of the transversals. Some important properties. These properties you have learned in the previous standards also. When the two lines intersect, the pairs of opposite angles formed are congruent. The angles in a linear pair are supplementary, means sum of the angles is equals to 180. When one pair of corresponding angles is congruent, then all remaining pairs of the corresponding angles are congruent. When one pair of alternate angle is congruent, then all the remaining pairs of alternate angles are congruent. Now see this figure. Here is alternate angles. These two lines are parallel. They are the congruent. This is also the two lines. They are the parallel. Alternate angles paired as a congruent. Now the next. When one pair of interior angles on one side of the transversal is a supplementary, then the other pair of the interior angle is also supplementary. Now let us learn the properties of parallel lines. We have verified the properties of angles formed by transversal of two parallel lines. Let us now prove the properties using the Euclid's fifth postulates given below. What was that fifth postulates? If sum of two interior angles form on one side of a transversal of two lines is less than two right angles, that is less than 180 degree, then the lines produced in that direction intersect each other. By using these fifth postulates, we will prove the theorem of the interior angle, that is interior angle theorem. Now we'll start very important theorem, that is the interior angle theorem. What is that theorem? If two parallel lines are intersected by a transversal, the interior angles on either side of the transversal are supplementary, means sum of the measures of interior angle is equals to 180. Now we will prove this theorem. Given line L is a parallel to line M and line N is their transversal. Hence, as shown in the figure, angle A, angle B are the interior angles formed on one side and the angle C and angle D are the interior angles formed on the other side of the transversal. This is given in the given of the theorem. That is, we describe here the description of the figure, and in the proof part, that is to prove that, what is to prove? The last sentence is important, that is a supplementary. The sum of the angles is a supplementary, means their measure is 180. Measure of angle A plus measure of angle B is equals to 180, and the measure of angle D plus C is equals to 180. Now see this figure. Line L and M, these are two parallel lines. N is their transversal, and the measure of angle A plus measure of angle B is equals to 180, means they are supplementary. Measure of angle C plus measure of angle D is equals to 180, means they are supplementary, and this we want to prove. We will prove that the measure of angle A plus B is equals to 180. Now there are three possibilities arise regarding the sum of the measures of angles A and the angle B. What are their possibilities? That is the measure of angle A plus measure of angle B less than 180. Measure of angle A plus measure of angle B is greater than 180, and the measure of angle A plus measure of angle B, that is equals to 180. These are the three possibilities. Now let us assume that the possibilities, the first possibility, that is true. That is the measure of angle A plus measure of angle B is less than 180 is true. Note that we want to prove that the measure of angle A plus B is equals to 180, but we are assuming that the measure of angle A plus measure of angle B is equals to 180 is true. According to the Euclid's postulates, if line L and line M are produced, will intersect each other on the either side of the transversal where A and B are formed. That is, according to the Euclids, if we extend these two lines, they will intersect each other at a single point. But the line L and M are parallel lines, that is we have given, and therefore measure of angle A plus measure of angle B less than 180 is impossible. When this happens? When the measure of angle A plus B is less than 180, and if we extend these two lines, they will meet each other. But this is not possible because we have given that these two lines are parallel, and hence that is a contradiction to our given, and therefore the first possibility, that is a measure of angle A plus measure of angle B less than 180 is impossible. Now for the second possibilities, now let us assume that the measure of angle A plus measure of angle B is greater than 180 is true. Now in this case, that is a measure of angle A plus B is greater than 180, but angle A plus angle D is 180, angle C plus B is 180. Now see this, angle A plus D is 180 because they are linear pair, Angle B plus C is 180. Again, they are the linear pair. By using this, A plus D is 180, C plus D is 180. They are linear pair. And if we add these two, that is A plus D plus C plus B, then you will get 180 plus 180, and that is equals to 360. Therefore, angle C plus angle D is equals to 360 minus, if we take this A and B on the right hand side, then it will like this. That is a measure of angle C plus measure of angle D is equals to 360 minus angle in bracket angle A plus angle B. Now, if the measure of angle A plus B is a greater than 180, then what will happen? That is a 360 will be less than 180. That is a 360 minus in bracket A plus B. This quantity will be less than 180. But that is, if this is less than 180, then according to again the Euclid's fifth postulates, if we extend these two lines, they will meet each other. But we have given that the line L is parallel to line M. Therefore, our second assumption, that is a measure of angle A plus measure of angle B greater than 180, is false. It's a contradict. And this is not possible. And therefore, the remaining possibility, that is, we have considered in starting, that is the A plus B is equals to 180. This will be the true for this. Now see this. That is a measure of angle A plus measure of angle B is equals to a 180. This will be the true. And similarly, we can prove that measure of angle C plus measure of angle D is equals to 180. And hence, that is, when the two lines are parallel, the sum of the interior angle is equals to 180. We have proved. That is, measure of angle A plus measure of angle B is equals to 180. Measure of angle C plus measure of angle D is equals to 180. But when this happens, the lines are parallel. This is the important theorem. And this. Now the next, the corresponding angles and the alternate angles theorem. By using this interior angle theorem, the corresponding angles formed by a transversal of two parallel lines are of equal measure. That is, in this figure, the line L is a parallel to line M. N is their transversal. The corresponding angles, that is angle A and the angle B, are the congruent. This we want to prove. Now see this here. Given line L is a parallel to line M. N is their transversal. We write in this given. What we want to prove, that we write into proof. That is a measure of angle A is equals to measure of angle B. This we want to prove. It's very interesting and simple theorem. Now see this angle A and C, these are the linear angles and sum of their angles is equals to 180. Therefore, measure of angle A plus measure of angle C is equals to 180 angles in linear pair. Now the next, B plus C is equals to 180. B plus C is equals to 180. That is, just we have proved the properties of interior angles of the parallel lines. Now see this, the right hand side of this equation 1, statement 1 and statement 2 are same. Therefore, the left hand side is also same. Therefore, angle A plus angle C is equals to angle B plus angle C. Now we can cancel on both sides this angle C, and hence we get angle A is equals to measure of angle A is equals to measure of angle B, and hence the theorem is proved. That we want to prove, that is angle A is equals to measure of angle A is equals to measure of angle B. And therefore, when the two lines are parallel, the angles formed, that is the corresponding angles formed by that two parallel lines are congruent. Now the next, the alternate angles formed by a transversal of two parallel lines are of equal measure. Now in this figure, line L is a parallel to line M. N is their transversal. Angle B and angle D, these are the alternate angles. And we want to prove that measure of angle B is equals to measure of angle D. Now given line L is a parallel to line M, N is their transversal. what we want to prove, that we will write into proof. That is angle D is equals to angle B. Now now see these two angles, that is angle C and angle D. They are the linear angles and sum of measure is 180. Therefore, measure of angle D plus measure of angle C is equals to 180, and this is one's first statement. Next, measure of angle C plus B is equals to 180. Again, we have proved the interior angles theorem for the parallel lines. That is, a C plus B is equals to 180. Now see these two statements. The right hand sides are equal. Therefore, their left hand sides are also equal. That is, a measure of angle D plus measure of angle C is equals to measure of angle C plus measure of angle B. We can cancel on both sides the measure of angle C, and hence we get measure of angle D is equals to measure of angle B, and hence when the two lines are parallel, their alternate angles are congruent, and we have proved it. Now let us start the practice set 2.1. It's very simple exercise. In figure, line RP is a parallel to line MS and DK is their transversal. Measure of angle DHP is equals to 85. Find the measures of following angles. That is, the angles RHD, angle PHG, angle HGS, angle MGK. Now see this, very important, that is we will prove here directly. Now the angle DHP and the angle DHR, these are the linear pair angles, and sum of their measure is equals to 180. Therefore 180 minus 85, that is a 95. Measure of this angle is 95. This is 95. This is the again 85, because these are the vertical opposite angles. That is the measure of angle RHG is equals to 85. Measure of angle DHR is equals to 95 by using the interior angle. By using the linear pair angles, we will get the measure of angle DHR. Again, the measure of angle RHG, that is equals to 95, because these are the vertically opposite angles. And again, we can get these remaining four angles. That is, a measure of angle HGS is equals to measure of angle DHP. This is 85, this is 85, because these two lines are parallel, therefore their corresponding angles are congruent. This is 85, therefore measure of angle HGS is equals to also 85. Again, the measure of angle, that is RHG, is equals to 85. Therefore, measure of angle, it's a corresponding measure of angle MGK. This is also 85, and in this way we will prove all the angles. Now see these step by steps. Now in this figure, measure of angle DHP is equals to 85 we have given. Now the measure of angle DHP plus measure of angle RHD is equals to 180. These are the linear pair angles. Therefore 85 plus measure of angle RHD is equals to 180, and therefore measure of angle RHD is equals to 180 minus 85, that is equals to 95. Therefore the measure of angle RHD is equals to 95. Next, measure of angle PHG. Now this is a 95, therefore these two are the vertically opposite angles. Therefore measure of angle PHG is equals to also 95. That is the measure of angle PHG. PHG is equals to measure of angle RHD. These are the vertically opposite angles. Therefore the measure of angle PHG is equals to 95. Next, measure of angle HGS. Measure of angle HGS is equals to measure of angle DHP. These are the corresponding angles. Okay, and therefore measure of angle HGS is equals to also, that is a 85. Because these two lines are parallel, because they are transversal, they are corresponding angles. That is, we know the measure of angle DHP is equals to 85, and hence we get the measure of angle HGH is equals to 85. Next, measure of angle MGK, that is measure of angle MGK. Now that is a measure of angle DHP is a congruent to measure of angle MGK, that is a alternate exterior angles. This angle, that is a measure of, that is angle T, H, P, and the measure of angle M, G, K. These are the exterior alternate angles and their measures are equal. Therefore, that is equals to also 85. Now the next question is also very simple. In this figure, line P is a parallel to line Q and the line L and M are their transversals. Now find out the measure of angle, that is A, B, C, D. Now let us start. Now in this figure, that is a measure of angle A plus measure of angle, that is a 180, 110 is equals to 180. That is the angle. These are the angles in linear pair. Therefore, measure of angle A is equals to 180 minus 110. Therefore, you will get measure of angle A is equals to 70. It's clear that these are the linear pair angles. The sum is 180. Therefore, A is equals to 70 degree. Now next, suppose that the vertically opposite angles, that is a B and E. Suppose I say that this is a measure of angle is E as shown in the figure. Now in this case, as these two lines are parallel, angle A and angle E are the corresponding angles. But we know the measure of angle A is equals to 70. Therefore, E is equals to also 70. E and B are vertically opposite angles. Therefore, the measure of angle B is equals to 70 degree. Also, A and B are exterior alternate angles. Measure of angle B is equals to 70 degree. Therefore, E is equals to E is equals to 70 degree. And also, measure of angle B is equals to is congruent to measure of angle E. They are the vertically opposite angles. Therefore, the measure of angle B is equals to 70 degree. And the lastly, that is we'll find out the measure of angle D. That is a measure of angle. First of all, the C. Now again see this, the line P is a parallel to line Q. M is their transversal, angle C and the 1150. These are the corresponding angles. Therefore, the measure of angle C is equals to 115. That is, they are the corresponding angles. Now next, angle D and this 115, these are the linear pair angles, 115 degree. These are the linear pair angles. Therefore, measure of angle D plus 115 is equals to 180. Therefore, the measure of angle D is equals to 180 minus 115, and that is equals to 65, measure of angle D. Now the next, in figure, now here is a question number 3. Now the question number 3, in figure, line L is a parallel to line M and line N is a parallel to line P. Find the measure of angle B, A, B, C. Now let us start. Now in this case, suppose that this is an angle measure of angle 45 and the E is a vertically opposite angles. Therefore, the measure of angle E is equals to also 45. E and D are the alternate angles. Therefore, D is equals to 45. Again, E and A are the interior angles. Sum of measure is 180. We can find out measure of angle A. By using that measure of angle A, we will get measure of angle B and measure of angle C. Now let us start. Measure of angle E is equals to 45. That is vertically opposite angles. Angle E and angle D are alternate angles. Therefore, measure of angle D is equals to 45. We get here is a 45. Next, measure of angle A plus D, that is they are the linear angles. Their sum is 180. Therefore, measure of angle A plus 45 is equals to 180. Therefore, measure of angle A is equals to 180 minus 45. Therefore, measure of angle A is equals to 135 degree. That is, we get measure of angle A. Now the next, A and B are the vertically opposite angles. Therefore, angle B is equals to 135 degree. Now we get the measure of angle B also. Also, B and C are the corresponding angles. Therefore, the measure of angle C is equals to 135 degree. And in this way, we have calculated all the measures of angles, that is A, B, C in this way. Now the next question. It's very interesting answer that all the measures of angles are 135 degree. In figure, side of the angle PQR, sides of angle PQR and the sides of angles XYZ are parallel to each other. Then prove that the measure of angle PQR is a congruent to measure of angle XYZ. Means sides of the angles XYZ is parallel to sides of angle PQR. Means XY is a parallel to PQ and YZ is a parallel to QR. When this happens, the measure of angle XYZ is equals to measure of angle PQR. Now let us will prove. Let ray YZ intersect ray PQ at S such that Y lies between S and Z and S lies between P and Q. That is, extend the ray YZ in backward direction. It intersects the ray QP at the point C. Now see this here. These are the two parallel lines and the measure of angle XYZ and the measure of angle PSZ. PSZ, these are the corresponding angles. Their measures is congruent, their measures are equal. Next, SZ and the QR are the parallel lines and we'll consider that is a ray QP is their transversal. Again, the measure of angle PSZ is equals to measure of angle PQR. Hence, this first angle is congruent to the second and second is congruent to third. It means that the first is congruent to second. It means that measure of angle XYZ is congruent to measure of angle PQR. Now we'll prove here. Now ray YX and is a parallel to ray QP. Ray YX is a parallel to ray QP. Line SZ is their transversal. Therefore, the angle XYZ is a congruent to angle PSZ. XYZ is a congruent to PSZ. These are the corresponding angles. Next, this is one. Now next, line SZ is a parallel to line ray QR and QP. Ray QP is their transversal. Therefore, angle PSZ is a congruent to angle PQR. These are the corresponding angles. Now see this. This is the second statement and this is the first. What is the common for these two statements? This is the PSZ is common, PSZ is common. What are the different? Angle XYZ, here is angle PQR, and therefore from 1 and 2, measure of angle PQR is a congruent to measure of angle XYZ. Measure of angle PQR is a congruent to measure of angle XYZ, and hence we have proved it. Now the next question, that is a question number 5. Line AB is a parallel to line CD and the line PQ is transversal. Measure of one of the angles is given and hence find the measures of the following angles. That is a measure of angle ART, measure of angle CTQ, measure of angle DTQ and the measure of angle PRB. That is a measure of angle first ART. Now these two angles are linear pair angles. Their sum is equals to 180. That is 180 minus 105. You will get the measure of angle ART is equals to 75. Therefore, the measure of angle PRB is equals to also 75 because these are the vertically opposite angles. Measure of angle PRA is equals to 105 because measure of angle ARP is vertically opposite to measure of angle BRT, and therefore we get all the angles in this way. Now see this first measure of angle ART. Measure of angle ART plus measure of angle BRT is equals to 180. They are linear pair angles. Therefore measure of angle ART plus 105 is equals to 180. Therefore measure of angle ART is equals to 180 minus 105. That is equals to 75. We get measure of angle is 75. Now next, measure of angle CTQ. CTQ is a corresponding angles. It corresponds to the angle angle ART. Therefore, this is 75, this is also 75. Because these two lines are parallel, their corresponding angles are congruent. Therefore, as the line AB is a parallel to line CD, PQ is their transversal, angle CTQ is a congruent to angle ART, they are corresponding angles. Therefore, the measure of angle CTQ is equals to measure of angle ART is equals to 75, and hence measure of angle, that is a CTQ, is equals to 75 degree. Now the measure of angle CTQ is equals to 75. Now we'll find the measure of angle DTQ. Now again, these are the corresponding angles. That is, or we'll apply here the linear pair angle. That is the DTQ, measure of angle DTQ plus measure of angle CTQ is equals to 180 angles in linear pair. These are the linear pair. Also, these are the corresponding angles. We can also prove that. Therefore, 75 degree plus measure of angle DTQ is equals to 180, and hence measure of angle DTQ is equals to 180 minus 75, and hence measure of angle DTQ is equals to 105. Next, measure of angle PRB, measure of angle PRB. Now the measure, these are the again vertically opposite angles. PRB is equals to, or we will apply here linear pair, that is a measure of angle PRB plus measure of angle BRT is equals to 180. Therefore, measure of angle PRB plus 105 is equals to 180. Therefore, the measure of angle PRB is equals to 180 minus 105, and that is measure of angle PRB is equals to 75. And in this way, we have completed the practice set 2.1. Now we'll see in the next video. Till then, goodbye.